the 6.1, and you can look at the title of the topic, which says we need to verify trig identities. Okay. But you remember that those ones you saw on the previous page are identities. So, but we're not verifying them because those are something that you assume to be correct no matter what. Right? Those are like the building blocks. What you have to verify will be the identities are a lot more complicated than the ones you already have on the previous page. But can anyone tell us what does the word identity mean to you? Well, you know what? Let me. Oh yeah. You want to take a picture? Now, if I call them identities, right? Reciprocal identities, right? Quotient identities, even odd identities, right? What does it mean? Something's an identity. Matteo? Equation, right? So, I agree with that because, almost always that you get an equation, right? When you see something like identity. Okay. Now, anything else? What might the identity look like? Or somehow, if you have to explain to someone who has no idea, what identity is, right? They have no idea what the terminology was. So you're trying to explain to them, hey, this is an identity. A very fundamental and basic conclusion, right? And when I say it's fundamental and basic conclusions, that means they must be right, right? And they must be right no matter what, right? It's like a golden rules. So basically, that's a true statement, right, in math. And also sometimes people refer to them as formulas, right? So go get yourself some formulas to use, right? Plug in numbers, right? So they are equations, they're formulas, they're true statements, right? They are conclusion, right? Which are true and correct no matter what. So now, how do we verify identities like that? Let's take a look at one of those examples in the textbook. And they say verify this identity, right? Which is an equation, right? But the problem is, now if you do see an equation, right, how do you know it's correct or it's valid? Okay, so hopefully you'll be able to write that equation into some form that just looks like the ones that you take for granted, right? Yes, but sometimes it doesn't work out very well. Okay. So let's say if I ask you guys to take some number for x right now with your calculator and plug it into both sides of identity to see if that will still be a valid equation. Or how about you take x to be 45 degrees? Now go ahead and give it a try. And trust me that this is also a pretty useful technique for our test. So use the calculator to help you to at least know if that could be a correct identity or not, right? Now, if you've done it, let me know what is the left-hand side of the identity once you plug in 45 degrees for x. It might be a decimal. I just need to know like roughly how much it is. What do you guys get? You guys be able to type in like secant x in the calculator or secant of something? You don't have a separate button, right? You have to remember that secant is 1 over sine, right? So unfortunately, you have to do 1 over sine 45, right? Times tangent 45. Okay, and work it out in a calculator. I guess that it should be I guess like a 0.7 or something. No, not 0.7 or something. 1.4, because I remember that secant is radical 2, right? Something like that. You guys get 1.4 or something? Oh, good. Yeah. So the left-hand side works out as radical 2. And if you try that for the secant 45, it will work out as radical 2. Right? Well, that's a way to verify, the identity. But now the problem is mathematicians not going to be happy about you just doing that for one value of x, right? So you say, what if, that might not be a correct valid equation when x takes some other values, right? That just might be a happy coincidence. So now you know that it's pretty much just asking you to compare the left and right hand side, right? So if you do have, some numbers to work with, if the left hand side works out as a number the same as the right hand side, then the identity is verified. But what we need to show, let's say at least if you're coming for the test or even a quiz, you need to show me that the left hand side works out exactly like the right hand side without plugging any explicit numbers for x. Okay, so now this is what we're going to do. Let's start from the left hand side. You're probably going to see me putting this down a lot. So LHS stands for the left hand side of the equation. So the title says that, hey, that's a strategy. Why don't you try to change everything into sines or cosines? Because I'm sure that you know that the secant, cosecant, tangent, they are not as nice as sine and cosine, right? So let's rewrite them using the identities you have to remember or from the picture you just took. So the left-hand side, now, if you don't mind, let me get rid of that. How should I rewrite cosecant x in terms of sine or cosine? What do you think? Cosecant x must be 1 over sine x. Okay, so now what about tangent x? In terms of sine and or cosine, so it must be sine x over cosine x, right? That's called quotient identity. Now, as soon as you see that there's a sine function on the denominator, but the same thing appears on the numerator, would you just go ahead and cancel them? Even though that they are not numbers, right? We know that they are the same thing, right? So, I mean, if we really cancel them. Yes, Lucia? That's a good question. So this is why, so as you're getting more and more experience, so you want your identity sometimes, right? So that's why you're going to see more scenarios. But you see that the title says that if you don't know what to do, like you said that, how am I supposed to do that? I'm not supposed to use cotangent, right? Change everything into sine and cosine. Yeah, that's like, it won't hurt if you try that, and most likely it's going to work out. If it doesn't, then we have some other strategies. So now when the sines cancel, it's left with 1 over cosine, right? And there's not much you can do anymore, right? Since that's already in cosine, right? And it's not a number, you have to leave it like that. Now, what about the right-hand side? Right-hand side is secant. Sure, you know that secant is indeed 1 over cosine, right? So, and it turns out that's it, right? So now, if you want to say something, you could, right? You say, well, the identity has been verified, right? Or mission accomplished, right? Whatever, right? But you don't have to, because, I can see literally you rewrite, with identities, right? This is reciprocal identity, quotient identity, right? Quotient identity, reciprocal identity. The left-hand side, right-hand side are exactly the same. And you see that Doesn't matter what value of x you're going to take, that works out. Okay. So how do you feel about the whole process? Would you say that if you know those basic identities, and this is probably just very simple algebra, right? So there's nothing hard or complicated you have to comprehend. It's just that you need to get used to the way of we verifying identities in general, right? Not playing with the numbers. Okay. And again, what you also have to take away from this problem is, just like Lucia says, that how am I supposed to use, how am I supposed to know what identity to use? One of the guidelines is use the sine and cosine, or whatever identities can take those equations and transform them into things about sine and cosines. Right, that's one of the strategies. All right, so now moving on. Now they say, hey, what about factoring? I know that sometimes, you know, that could be quite hard to visualize the factoring if things are not in a polynomial form. So let's say, does anyone notice a common factor for these two terms on the left-hand side of the equation? And what is that common factor? Sine of x, right? So now again, it's not necessarily a numerical factor, right? Not a polynomial factor. It's a factor of a function sine of x, right? So to factor it out, if you notice, that the left-hand side of the equation in a form of something, right? Let's call it a minus a times something else. Let's call it b squared, right? So this is like, I'm thinking that the sine is letter a, right? And cosine is letter b, right? And sine and cosine squared is multiplying each other, right? So now you're looking at a more like a polynomial pattern. How would you factor out common factor a? So if I take it out, right, and I need to put it next to a pair of parentheses, what do I put in a parentheses? -1, or would it be 1? Now, the way you can tell whether it will be either a number or whether it should be a positive or negative number is, what if you distribute this a? Do you still get the same thing back? If you put -1, right, when a hits -1, you get negative a, right? So that's not the same thing as the first term anymore. So now, would you guys be able to take a guess of the second term once the a is factored out, right? So what kind of form it has to be so that if you distribute a, you do get back -a times b squared. So we should have a negative sign, right? And we should have a b squared. Does it make sense? Distribute a, let a hit the first term, a times 1 is a, right? When a hits the second term, you get ab squared, right, with a negative sign. So now let's do that to the left-hand side of the equation. We'll factor out not a anymore, right? Let's factor the sine of x. Right, so the left-hand side becomes sine of x factored out, right? And this becomes 1, right? Minus cosine squared x. And again, quickly do a sanity check. If I distribute the sine of x, does it become the same as before? Yes. Right? But now, what do we do? I mean, we're kind of stuck, right? So things are in sine and cosine, and we already did the factoring. Unless you notice that this is also further factorable, right? 1 minus cosine squared using the difference of squares. But you need to have a good reason why you have to do it. I'll say that keep an eye on the right-hand side. That's your ultimate goal, right? So you want to show me that the left-hand side looks just like the right-hand side. But do you see that word get sine of x, right? But there's no cosine x on the right-hand side. So we hope that maybe I can get rid of the cosine x, right, on the left-hand side, and hopefully I'll get sine of x. So now the question becomes, is there a way, or if you notice any identities in the picture you just took, that can turn this combination 1 minus cosine square, or it turns cosine square into sine square, or something to, the sine of x, because I want everything to be the, sine of x, so then hopefully it will be the same as the right-hand side. You guys notice any identity from that picture you just took? I'm looking for something that has, okay, Malachi? Okay, that's an identity has that magical 1, right? That's like one of the identifier, and also it has the square, the cosine, the sine square, right? So probably that's the one, right? Yes. So let's give it a try. So I notice sine square of x plus cosine squared x equals 1, right? So like I said, I don't like the cosine square anymore, right? I want everything about sine, right, on the left-hand side. So I'm going to solve for cosine square, right? How would you do that? Subtracting sine of x, well, sine square, right? So would you say that this is telling us that cosine square x is 1 minus sine squared x? Am I right? Okay, so now remember our goal is to get rid of the cosine square, right? Let's go ahead and plug it in. I still have the sine of x. All right, so I'll make a bracket, and you'll see why in a second. 1 minus. So whenever I see cosine square, I need to replace it with this guy, right? 1 minus sine squared x. Let's simplify it. All right, so now how would you get rid of parentheses? There's a preceding negative sign, right? So would you lose the parentheses, but you have to flip the signs in front of every single term, right? So the first term was a 1, but it becomes negative 1. And that second term was negative sine square, but it flipped the sign to become positive sine squared x. And then you realize that 1 negative 1 cancels. You're left with sine x times sine squared x, which can be combined as sine to the third power of x, right? And that's indeed the same as the right-hand side. All right, so now what about this one? Anything that might have bothered you already? Well, maybe the factoring pattern, right? Not that obvious. I don't blame you because, you kind of have to, try a few more rounds of these kind of a factoring, then you get used to it. And then something else like looking for an identity that can help you to proceed, right? You have a clear goal that what was wrong with the cosine because you want the sine square, right? Or sine, something to do with a sine on the right-hand side. So you better get rid of the cosine. And that seems to be the best identity that's relating to sine and cosine, right? And also that magical one that reminds you that might be also the one you're looking for. So now you rewrite this equation to isolate the cosine, so you can plug it in as if you're solving for like a system of equations, right? With the substitution. And later on, you have only, the sine square going on, right? Simplify as much as you can. And again, you should have the faith that, if you're actually trying to get to something that you're supposed to see on the right-hand side, and you're moving in that direction, it's going to work out. But I see a lot of the time, our students probably going to pause at this moment, or even here. So that way, it looks just so complicated. It doesn't look like the right-hand side. I said, well, don't stop, right? Simplify it, because sometimes the answer might be just right in front of you. We have to go through those superficial stuff, right, and see that the truth at the end. All right. Now, one more. I think that you're probably gonna get the general pictures of what we're trying to do with those identities, and more likely, how do we verify it? Okay. But before I move on, again, any other questions about this problem? So now it's just identities you have to remember, and some algebra they have to recall back in maybe algebra 1 or 2. All right, so now this one. I guess that you realize there are quite a few things they're getting a little bit more concerning than the previous problems. First off, you do have cosecant. That means you might have to turn it into, 1/sine. But that's not the only issue. What's worse is the right-hand side has denominators, right? And you actually have two fractions with different denominators. But somehow they insist that you might want to combine the fraction expressions, which is on the left-hand side, right, to verify this identity. So now the question is, how would you be able to combine these two fractions if they have the same, different denominators? And let me remind you with a simpler numerical situation. Let's say 2/3 plus, let's say 5/4, just making that up. So how would you add up these two fractions? Yes, you need the common denominator, right? And what would it be for 3 and 4? 12. And that happens to be the least common denominator, right? And you get it from multiplying 3 and 4. So you can always do that. But sometimes with the numbers, you cannot be you have to be a little bit careful, because things might not be always just simply multiplying them. Like, what if you have 2/9 plus 5/18? What will be the common denominator or least common denominator? It's 18, right? Can you do what is that? I can't even do it. 162, not 62. Yeah, 162 or something like that. So by multiplying them, you are getting a common denominator, but not the least. But what's going on over there? You have these two denominators, one plus cosine, and the other is sine. They don't have anything in common, just like 3 and 4, right? So I'll say that your best bet will be just multiplying them. But you don't have to simplify the product of 1 plus cosine and the sine, because you can ask yourself, we're going to do that combination if you already know that the common denominator is going to be 3 times 4. So you rewrite the first fraction as still 2/3. We're going to multiply both numerator and denominator with 4, right? To turn the denominator into the common denominator, the least common denominator. Now, for the other guy, instead of multiplying 4, you're actually going to multiply the 3, because that's the other denominator that combines with the 4 to get to the least common denominator. And once you're at that stage, you realize that, oh, they're both over 12, right? So I can add up the numerator, 2 times 4 plus 5 times 3, right, over 3 times 4. I could work them out, but I want to see that how those number goes, right? Then you know what to do. So let's reproduce the whole process. But we try not to spoil ourselves with just the numbers, right? We'll deal with same thing, but with sine and cosine stuff. All right, so the left-hand side is two fractions, right? The first one, I'm going to rewrite it as sine of x over 1 plus cosine of x. I'll enclose 1 plus cosine of x in the parentheses, and you'll see y in a second. So let me multiply I guess I could do a different color. So multiply both numerator and denominator with sine of x. But don't confuse yourself that you saw, oh, I'm just multiplying the same thing as you saw on the numerator. No, I'm multiplying the sine of x because I see that this is actually the second denominator, right? Just like 3 and 4. So I'll rewrite the second fraction the same way. Right, so I'll enclose 1 plus cosine in a pair of parentheses, right? And I'll multiply the other denominator, which unfortunately is going to be 1 plus cosine, right? And at the bottom, there was a sign there. But you know what? I think that I want to be consistent with the color. Let's do the 1 plus cosine x here, right? 1 plus, cosine x, right? So you always multiply the same thing on the top and the bottom, but what you have to multiply the current denominator with depends on the other denominator. That's all, right? It's like a swap with a cross multiplication kind of thing. So now you go ahead and combine the numerator, right? The first one reads sine squared x. The second one, unfortunately, you have to FOIL it. I'll first write it out before I do that. So the denominator is going to be a common denominator, 1 plus cosine x, okay, parentheses, sine of x. I know that people's going to complain about how am I supposed to know that I need to FOIL it, but that's the kind of experience you're getting from these problems, okay? So we have sine squared x. So now if I FOIL these guys, I'll get the first term, which is just 1 times 1, right? That will give me 1. Then the first term will be 1 times cosine, right? Sorry, not the first term, the outer term, right? So it will be cosine x. Then the inner term will be cosine x times 1, so it will be still cosine x. And the last term will be cosine square. 1 plus cosine x times sine of x. Can I further simplify the numerator? You guys notice any interesting combination of sine and cosine? They might be a little bit farther away from each other. See those two guys, right? I mean, now you should be kind of alerted, right, to those combinations of sine squared and cosine squared. Let's move them together. Sine squared x plus cosine squared x, right? Plus that 1 get copied over. Get 2 cosine, right? So it'll be 2 times cosine x over 1 plus cosine x times sine of x. And you realize, according to the Pythagorean identity, cosine squared plus sine squared will be 1. You have 1 plus 1, right? You get 2 plus 2 cosine x over 1 plus cosine x times sine of x. Well, what next? You guys have any suggestion? Or take a look at what's on the right-hand side, because that's your ultimate goal, right? The right-hand side is 2 cosecant x. If we turn a cosecant into the sine, it will be 2 over sine, right? Well, I have a sine there. That's already on the denominator. And I have a 2 on the top. Maybe I could factor out the 2, right? Remember that's what you did in a previous example, right? So let's factor out 2 on the top. I factor out 2. Can you guys tell me what's going to be left over in a parentheses? The first, okay, 1 plus cosine, right? And now you quickly distribute the 2, you do get the same thing back. over 1 plus cosine x times sine of x, and the good news is they do cancel, right? So that gets you the same thing as the right-hand side, or if you know, if you do want to write down one more step, you can put the right-hand side is indeed, by referring to the reciprocal identity, is 2 over sine of x, right? And that's, like I said, unfortunately, a lengthy process, okay? And that's, you know, all I want to do for today, just to get you started thinking about, I know it's kind of a boring and tedious algebra. So, like I said, maybe give it a try to the first couple problems in the quiz packet. You'll see that it's probably they're not too bad. But definitely, you know, set aside some time to go over those problems, learn from the example, right? Or maybe some interactive examples in the homework, but definitely don't wait too long to get started.